All right, so today we're working on the Chapter 8 and 9 review. Questions 1 through 3 ask us to perform the same skill over and over again. So we're going to be, for each of the rational functions, we're going to be identifying the vertical and horizontal asymptotes. We're going to be saying where the x and y intercepts are, and then we're going to be graphing the functions as well. So there's a couple steps that are involved in each of these. As you're doing the work for them, make sure to refer back to your notes, especially for the notes on horizontal asymptotes, because that's the part that most people forget. So the first one says f of x is equal to x minus 3 over x plus 1. So this is the function that I'm going to be graphing. Before I start graphing where the function is, I'm actually going to graph where the function is not. So I'm going to choose to start this graph by identifying the asymptotes, or the places where the graph does not cross over. Remember from your notes that asymptotes are usually indicated with a dashed line, whether they're horizontal or whether they're vertical. So to find the location for your vertical asymptotes, you're going to look at the graph, and the vertical asymptotes are whatever would make the denominator equal 0. So they're similar in concept to excluded values. So if this denominator is x plus 1, my vertical asymptote is going to be the vertical line, x equals negative 1. So it's the number that's going to make the value of that fraction equal 0. We can come over to our graph, and we can graph that vertical asymptote here. So it's a vertical line that the graph that I eventually draw on this graph won't cross. And so that's going to be one of the lines that this graph doesn't cross. To find my horizontal asymptote, I need to do something a little bit different. So when the degree of the numerator, x to the first, is the same as the degree of the denominator, x to the first, my horizontal asymptote is located at the ratio of these coefficients. So 1 divided by 1 gives me 1. So for this problem, my horizontal asymptote is going to be located at the line y equals 1. And so that's going to be a horizontal line that cuts across the graph there. A lot of times students find it helpful to start by graphing their asymptotes. After they graph their asymptotes, they'll go through and they'll find their x and y intercepts. And then all you have left to do once you know your x and y intercepts is find two other points on the graph that kind of help you sketch the curve of the graph. So when I find my x and y intercepts, depending on how your teacher showed you this in class, when I find my x-intercepts, I'm going to put zeros in for my y, and when I find my y-intercept, I'm going to put zeros in for my x's. Remember that f of x right here, that's just the same thing as y equals, so if you want to, you can scribble this out and write that this is y equals right here, and it just means the same thing. So to find my x-intercept, I'm going to put 0 in for my y, and then I'll solve the resulting equation for x. And to find my y-intercept, I'm going to put zeros in for where my x's are, and then I'll solve that equation for my y. So over here, I would times both sides by x plus 1, because that makes the x plus 1 cross out with the x plus 1 over here. Anytime you're finding your x-intercept, you're kind of just setting your denominator equal to 0. So you can remember that as a shortcut if that would help you. For your y-intercept, when I put my zeros in for my x's here, I'm basically just dividing those two numbers with each other. So negative 3 divided by positive 1 is going to give me negative 3. So for my x-intercept for this first problem, my x-intercept is going to be at the point 3, 0, and my y-intercept is going to be at the point 0, negative 3. So this is going to be one of the points on my graph. That's my x-intercept, and then that's going to be my y-intercept. Knowing where those 2 points are located and seeing how the graph is split by the asymptotes, you can use this information to help you draw part of the curve. And so this graph is going to be coming in from this direction, and then it's going to bend and come down here. So it's going to follow sort of that pattern that I just outlined in pencil. You don't have to worry super precisely about where it goes. Just remember that it's never going to cross the dashed line for the asymptotes. So because these 2 points were over here, I knew this part of the graph, or this curve of the graph, was going to be in this area. And I also know that it means that the other curve, or the other part of the graph, is going to be in that area over there. The way that your teacher recommends that you find points over here might vary teacher by teacher. But so you already picked, or you already know 2 points that are to the right of the vertical asymptote. So you already know that, let's see, you already know that 0 goes with negative 3, and you already know that 3 goes with 0. And so this dashed line that I drew here in between on my table just indicates the location of where that vertical asymptote is. So to finish sketching the graph over here, you're going to want to pick 2 other points that would lie in this area of the graph. You can be smart and try to pick numbers that'll give you whole number answers. You want the numbers to be smaller than -1. So if I plugged in a -2, it's not going to be that bad. And if I plug in a -3, it's not going to be that bad. So those are the numbers that I would choose to plug in, just because I quickly glanced here and here, and I made sure that I noticed that it was going to give me like pretty answers for the question. So I'll plug in the -3, and I'll simplify. So when I plug in a -3 into my graph, it says that I get 3 out as my answer. And so -3, 1, 2, 3 is going to go with +3, 1, 2, 3. So that'll be one of the points on my graph. And then I'm also going to plug in -2, so -2 minus 3. And I'm plugging them into this original function. That's how I'm doing the work right here. -2 plus 1. And then -5 divided by -1 gives you +5. I'm going to go ahead. I realize this graph is right here, so I'm just going to move these up a little bit. It'll give me some extra space when I graph the second one on the review. So I plugged in a -2, and I got out +1, 2, 3, 4, 5. And so even though these 2 points don't show you the full part of what's happening on this side of the graph, it at least shows you enough so that you can draw in the second curve of the graph. Remember, we're not super focused on having it be perfect. If we were, you would definitely be plotting more than just the 4 points. But plotting these points, the 2, the x and the y-intercept, knowing where the vertical and horizontal asymptotes are, and then plotting the graph, gives you enough information about that graph to be able to accurately answer the question. All right, so for number 2, the equation of the rational function that you're using for problem number 2 is f of x is equal to 2x minus 6 over x minus 2. And so for this one, the pattern is exactly the same as the pattern we followed up here. So my vertical asymptote is whatever number makes my bottom equal 0. So this graph's going to have a vertical asymptote at x equals +2. And so x equals +2 means there will be a vertical line located over here that this graph doesn't cross. And then for my horizontal asymptote, I need to look at the degree of the numerator and the degree of the denominator. So this is x to the first, this is x to the first. So the rule says that when the degree matches, it's the quotient or the ratio of the coefficients of the x terms. So 2 divided by 1 would give me 2. So my horizontal asymptote on this one isn't going to be y equals 1. It's going to be y equals 2. And so that would be the location for the horizontal asymptote there. Once I have those 2 figured out, next step is I'm going to find my x-intercepts and my y-intercepts. And so I'll do the workout and show those algebraically. You want to make sure that you do know how to show them algebraically, because this could be a free response question on the test where you have to show all your work. So just make sure that you're comfortable showing the steps for these as well. So for my x-intercept, I'm going to put a 0 in for my y, and remember that's my y right there. So I'll put a 0 in for my y, 2x minus 6 over x minus 2. And then for this one, the zeros go in for my x's, they don't go in for my y's. You'll multiply both sides by the denominator to cause the denominators to cross out over here, but it's just the same as setting the numerator equal to 0. So 2x minus 6. No more denominator on this one because it just eliminated. And then I'll finish solving the question to get the xl by itself. So I'll get x equals 3. So my x-intercept for this one will be at 3, 0. And then for this one, -6 divided by -2. So for this one, I'm going to get my y-intercept is also at +3. But the point for that would be 0, 3, not 3, 0. And so when I show the work for this problem, and I'm graphing it, you know what, guys? I'm actually going to slide this graph down here. So I'm going to omit that graph that's on the top part, just because I don't have enough space to do as solid of a job showing you the work. So I'm just putting the, I just moved the asymptotes from this graph down here. So I'm not going to worry, and I'm not going to use this graph right here at all. And then I'll do question 3 on another page for you so that we have enough work to see it. So don't worry about that graph there. This graph will go with this work. So I moved my two asymptotes down. 3 goes with 0, so that's my x-intercept. And then 0 goes with 3, that's my y-intercept. So this graph is a little bit different because now you have one point that's to the right of the vertical asymptote, and you have one point that's to the left. So when you make your table to finish out this problem, and I'll do the work for that up here, here's your vertical asymptote. So you know that 3 goes with 0, and you know that 0 goes with 3. But notice how I wrote 1 on the right and 1 on the left. I'm going to pick another point over here that will give me an answer to the question that's sort of suitable. The number 4 will give me an integer answer when I plug it in. And then I'll also pick a number that's over here. And it doesn't matter what number I pick. I just want it to be a number that's smaller than 2. So, for example, I could plug in the number -1 and get a number out for that as well. And so I'm just trying to complete the graph, and I don't want to draw the curve through just a single point. I'm going to draw it through 2 points. So when I plug in the -1, I'm plugging it into the function. I'm going to get, let's see, -8 over -3. So this one actually isn't going to work out to be a whole number. We're going to get 8/3 as your answer. But it doesn't matter that the number that I picked randomly didn't give me a whole number answer. It's fine because it's going to give me the practice of graphing this fraction. So I'm going to go ahead and leave it. Some students might want to change this number because 8 8/3 is 2 2/3. So if graphing the fraction doesn't make you happy, then you can always pick a different number that would give you a whole number answer. When I plug in the 4, let's see, so 2 times 4 minus 6 divided by 4 minus 2. So that's going to give me 8 minus 6 over 2. And so 8 minus 6 over 2 will give me 2 divided by 2, which gives me 1 out for my answer. So 4 is going to go with 1, and then -1 is going to go with 8/3. So 4 goes with 1, and then -1 is going to go with 2 and 2/3. So it's kind of in a funny spot. When I graph this graph, though, remember the portions of the graph that contain points from the function are going to be opposite each other. So this one's coming down from this direction, and again with arrows on the end. And then when I graph this one, it's coming, and I'm just going to overlap my work there a little bit, but it's coming in that direction. And so it gives you that curve. Let me just go over this in pen to make sure you guys can see it okay. It gives you that curve of the graph that's opposite the other curve of the graph. And so it gives you that location right there. So again, this was the work for number 2. We'll finish this section by doing the work for question number 3. And question number 3 for this one, the problem says, let's see, f of x is equal to x plus 4 divided by x minus 4. And so that's the problem that we're going to go through, and we're going to graph for this one. That's the problem that we're going to go through, and we're going to graph for this one. So when I draw the function, I'll do so over here on this coordinate grid on the right-hand side of the graph. So f of x is equal to x plus 4 over x minus 4. I have a vertical asymptote and a horizontal asymptote that I'm going to find. My vertical asymptote is whatever excluded value makes my bottom 0. So this one's going to be x equals 4. So 1, 2, 3, 4. So here's my vertical asymptote. And then my horizontal asymptote, the degree of this is 1, the degree of this is 1. So it's the quotient of, or the ratio of the coefficients. So this one's going to be y equals 1, because there's a 1 in front of the x, and there's a 1 in front of the x, so the top and the bottom. And so that gives me this horizontal asymptote. So those are the two crisscrosses on this graph that it's not going to touch, or it's not going to, the curves that you draw won't cross over. And so now I'll do my x and y intercept. So for my x-intercept, I put the 0 in for the y. And remember, I just did it automatically, but this is your y. And then for the y-intercept, I'll do the opposite, and I'll put the 0 in for my x. On this one, I'll times both sides by x minus 4. These will cross out. So I'll get 0 equals x plus 4. So my x-intercept for this one is going to be at the point -4, 0. And then for this one, I'll get y equals -1. So for this one, my y-intercept is going to be at 0, -1. So I know 1, 2, 3, 4. Here's my x-intercept, and then here's my y-intercept. On this graph, the two important points that you've located so far are over here on the left side of the vertical asymptote. So you can draw in, no, that wasn't very curvy. Let me try harder. You can draw in the sketch of what the curve on this side is going to look like. And so that's going to give you a portion of the graph. It may actually, in truth, come a little bit closer to this asymptote before it curves down. So let's do a better job sketching in this component of the graph. It might come a little bit more this way before it curves down. But again, as long as your graph crosses through the important x and y intercept, then you'll be good. And then to finish this one, dashed line, the 2 points that I have are both to the left of that line. So I know already that -4 goes with 0 and 0 goes with -1. So now I'm going to pick 2 points that go to the right of this. And it doesn't matter. 1, 2, 3, 4. My vertical asymptote was at x equals 4. So I'm going to plug in the number 5. And then I'm going to plug in the number 6. Because at my quick, first glance, it looks like those are going to give me whole number answers when I do the work. 5 plus 4 is 9. 5 minus 4 is 1. So 5 will go with 9. And then 6 plus 4 is 10, and 6 minus 4 is 2, so 6 will go with 5. And so 1, 2, 3, 4, 5, 6. Yep, just enough room to fit that one in. And then 6 goes with 5. 1, 2, 3, 4, 5. And so it's a little bit up higher, but this curve for this graph will follow, and I'm running out of paper right here, but it'll keep coming down and it'll curve along this direction as well. So when you're graphing these, sometimes students will find their asymptotes, they'll find their intercepts, they'll find their important points, but then students might start trying to connect these points and these points. Remember, the curve that you draw is never going to cross across, that sounds funny, it's never going to go across one of the asymptotes. So these dashed lines that you draw are sort of like stop signs. They're having you yield away from them. So you're not going to draw anything that goes across those lines. It's going to give you points, rather, where the graph is located. And so you can, as you're practicing these, just make sure that when you draw in this curve and when you draw in this curve for the graph of this rational function, it's never going to cross over an asymptote. So do keep that in mind. Let's see, next up, question number 4. We're done with the graphing component for all of this. So on question number 4, it says to identify the excluded values of the given rational expression. So my first one's x plus 7 over x minus 11. Remember, excluded values are the numbers that make the bottom be 0. So they're the bad numbers, or the numbers that you don't want to work with. So for this one, my excluded value would be, I don't want x to be positive 11. Positive 11 is the number when substituted into the bottom of that fraction would cause the denominator to equal 0. And in math, division by 0 is undefined. So that would be my excluded value for number 4. For number 5, x minus 1 over 3x minus 9. On a multiple choice question, you could do something like this in your head, but you want to be careful with how much of it you just try to do. It's easy to make mistakes when you're trying to solve for x in your head. So remember, if you don't want to do it in your head, you can say you don't want the denominator to equal 0. So if you don't want the denominator to equal 0, you don't want 3x to equal 9. And so you don't want x to equal 3. On a question like this, where it's a whole number answer, you might have been able to find that excluded value in your head, but just be careful on the ones where the work's a little bit trickier, or especially anywhere you get fractions. A point about these two before we move on, you don't care what the top is, because it's okay to have a 0 on the top of a fraction, you just can't have a 0 on the bottom, so it's good to make that distinction. I don't mind if x equals 1, but it's bad if x is 3, because 3 times 3 is 0, 3 times 3 is 9, and then 9 minus 9 would give me 0 for that part. Here's question number 6. Now this one's tricky because this one has 2 answers, and there's a couple different ways that you can figure out that this one has 2 answers. You could use a square root method of solving the denominator, or you could t-chart the bottom, and students will do it both ways. So you just want to make sure the answer for this isn't just 5, it's 5 and -5. So be careful with whichever way you show your work for the question. If you decide that you're going to factor, you would factor the bottom, so it would factor as x plus 5 and x minus 5 on a t-chart. and then you don't want that to equal 0. So you don't want x plus 5 to equal 0. So you don't want x to be negative 5. And then on this side, you don't want x minus 5 to equal 0. So you don't want x to equal positive 5. And so this question for number 6, it has 2 excluded values. Anytime you're factoring to find the excluded values, there's a chance that there could be more than one. So just double check and make sure that there's not another number that makes that equal 0. And then for the last one in this question, for question 7, negative 3 divided by... I almost don't even have to worry about writing down what's in the top of the fraction because I only care about what's in the bottom of the fraction when I'm doing excluded values. So for this one, I would t-chart my denominator. Negative 8 times negative 2 gives me back negative 16. And when I do my inside-outside on my FOIL, I get negative 6. So that's how I know I did this right. I don't want that product to equal 0. So I don't want x minus 8 to equal 0. So x can't equal 8. And then for this side, I don't want x plus 2 to equal 0. So I don't want x to equal negative 2. So for this rational expression, those would be my 2 numbers that would be my excluded values. So those are the 2 numbers that are bad. Looking back at the previous problems that we did, when we were finding vertical and vertical asymptotes, we were saying that x does equal the bottom of the number of whatever makes the bottom be 0, because this is the equation for a vertical line. So if you notice for all of these that we did, we said x equals 2, x equals negative 1, and then for the last question it was x equals positive 4, because that was the number that made the bottom be 0. But notice that for excluded values, we're using the does not equal symbol, and that's because you're saying that these are the numbers that make the bottom of the fraction be 0. So these are the values for x that you would not use in terms of evaluating the expression. So it's a distinction between the 2 of them, but it's helpful to make. On question number 8, where the directions say to simplify the expression, you want to make sure that simplifying an expression, so something that's a fraction, can only happen when that fraction is in factored form. So you want to make sure that you don't fall trapped to just trying to cross out like the x with the x or cross out the 3 with the 15. I need to hockey stick the top on this one, and so I'll GCF out a negative 1. I'll have x plus 3 left over. And then the bottom needs to be t-charted, and when I t-chart the bottom, I get x plus 5 and x plus 3. So when I change the way that this one's written, my top turns into negative x plus 3, the quantity of x plus 3. And then for my bottom, I have x plus 5 and x plus 3. And when you're simplifying these, you're going to simplify the ones that can cross out together. So this one crosses out with this one. And so my final answer for this problem is, let's see, it's going to be negative 1 in the top and then x plus 5 in the bottom. And you don't have to write it with parentheses in the bottom because there's no product with the number that's in the bottom. So you can just write it in that format and that answer would be correct in terms of the way the question is written. For number 9 has an x plus 6 in the top and it has x squared minus 36 in the bottom. This question looks a little bit simpler than this question does, but a lot of students still get it wrong because you want to just cross these out and get, I don't know, 1 over 6 is your answer. But you want to be careful because it's not being written in factored form. I still need to factor the bottom. So the bottom t-charts x plus 6, x minus 6. So as you're doing your work on this one turns into x plus 6 in the top, and then x plus 6 and x minus 6 in the bottom. Your x plus 6 in the top crosses out with your x plus 6 in the bottom, and so that's how you get 1 over x plus 6, x minus 6 for your answer. So you can't just cross off the pieces. You have to make sure that it's factored first, and then once it's factored, you can cross off the pieces for the factoring. Question 10. This one's going to have 2 t-charts. Remember, one thing you want to keep in mind with t-charting is that you always want to try to hockey stick or factor by GCF before you go through and t-chart. These ones don't have anything in common. These ones don't have anything in common. So I'm ready to just go ahead and t-chart both of them. The top t-chart isn't that bad. It's going to be x plus 5 and x plus 1. But when you t-chart the bottom, it has just different, anytime there's a leading coefficient that's not the number 1, sometimes that can cause people to kind of get tripped up a little bit when they're doing their t-charting. You might, even though you feel confident with this process, it might be helpful to draw out the little t-chart if this is the way that you learned how to factor trinomials. You want the 9 to be positive, so you want the 1 to be negative. So when this factors, it's going to be 2x minus 1 and x plus 5. Quick little hack for you on this. If you t-chart this and if you t-chart this, chances are one of them should match. So if you weren't sure where the negative 1 was supposed to go, it's probably going to go so that one of them matches, like here and here. So that can help you solve the question. Just a little tidbit. X plus 5 and x plus 1 in the top. 2x minus 1 and x plus 5 in the bottom. And then you cross out the ones that match. So the x plus 5s cross out. So your simplified answer for this one is going to be x plus 1 in the top, and then 2x minus 1 in the bottom. And then that does not simplify any further. So that's the furthest you can go with the answer to that question. And then here's 11. Negative 9x over 3x to the second minus 21x. Again, it's really tempting to want to cross out the 9 with the 21 or cross out the 9 with the 3, but the bottom of this fraction isn't in factored form yet. So I need to factor out the GCF and then write this expression in factored form and then go about crossing off anything that can cross off. So in this problem, I can't cross out the x minus 7 with anything, but the 3 and the 9 can simplify. The x and the x can simplify. And so when I'm done simplifying on this one, I have a negative 3 in the top and I have an x minus 7 in the bottom. And so that would give me my fully simplified answer for this one. So on question numbers 8, 9, 10, and 11, on the 3 that we just did, it started out with one fraction and the direction said to simplify. So I wasn't adding, I wasn't subtracting, I wasn't multiplying, I wasn't dividing. Oh, I guess you're dividing because it's a fraction. But I wasn't solving a rational equation like we'll do a little bit later on. For this part in the review, you're just given one fraction and you're asked to simplify. So what you want to remember when you're doing this is that you're going to factor and then simplify, factor and then simplify, factor and then simplify. Factoring will be important as you go through this process. For questions 12, 13, 14, and 15, you're finding the LCD. And so depending on the type of question that you're being asked for this, there may be more than one step that you need to follow to find the least common denominator. You're not actually adding or subtracting them, you're just trying to find the LCD. Before you can find the LCD of any kind of rational expression, you're going to want to go ahead and make sure that both denominators are written in fully factored form. So I can GCF or hockey stick out an 8 from the first one, and then I can GCF or hockey stick out a 2 from the second one. So this denominator turns into 8 times x plus 1, and this denominator turns into 2 times x plus 1. So I haven't actually found my answer yet. I'm just rewriting the work because I think it makes it a little bit clearer when you see it written out like it is. So I didn't change anything. I haven't made the bottoms the same. I just GCF'd out what could come out from both of them. They both have an x plus 1. This one has an 8, and this one has a 2. And so if I was going to be adding or subtracting them together, I could make them be the same by multiplying this fraction by the number 4. So for question number 12, it's asking me just to find my LCD. My LCD for this one, if I was going to add or subtract them, would be 8 times x minus 1. I wouldn't have to make it be 16x minus 1. I mean, I could, but that wouldn't be my least common denominator. That would just be a common denominator. And I'm trying to find the common denominator that's the least. So by multiplying this one by 4, the bottoms would match, and then I could add or subtract them together depending on what the question was asking me to do. All right, for 13. Here's how the problem starts. So x minus 5 over 5x minus 10. And then for my next one, it's 7x plus 3 over 2x plus 18. All right. So for this one, there's also a GCF in both of the denominators that I need to go ahead and pull out. So this one, I'm going to take out a 5. And then on this one, I need to take out a 2. So I'm not going to go ahead and keep rewriting them for all of the different problems, but you could rewrite this denominator in factored form if you wanted to. This one, the bottom would be 5 and x minus 2. And then for this one, it would be 2 and x plus 9. So that's what the bottoms would turn into if you went through the step of rewriting it. And you're trying to make these two bottoms match each other. So this one has an x minus 2. So if you were going to make them match, this one would need the x minus 2 and the x minus 2. This one has an x plus 9. So if you're going to make a match, this one would need the x plus 9 and the x plus 9. But then if you check, they still don't quite match each other because this one has a 5 and this one has a 2. So I can't turn a 2 into a 5 or a 5 into a 2, but I could make them both turn into a 10. So this one would need the 5 and the 5, and this one would need the 2 and the 2. So when all is said and done, on this one, my lowest or least common denominator is going to be 10. I'm going to need an x minus 2, and I'm going to need an x plus 9 for the problem. So having both of these as a part of my answer, or all three of these, I should say, as a part of my answer, that would be the LCD. Before we move on to 14 and 15, just remember your pattern for 12 and 13 so far is you factor the bottoms. You can rewrite them or not rewrite them. It kind of just depends on what you want to do. And then once they're rewritten, then you look at the bottoms and you decide what you need to do to make them be the same or match. And then that becomes your least common denominator. Later in the review, you'll be adding or subtracting these together once you find the LCD, but for this part, you're just trying to find the least common denominator. So you're just trying to go through and figure out what would the bottom be if you did have to add or subtract them together. So on question number 14 on the review, you're still finding the least common denominator. So for this one, your denominators are 8x plus 32. And then your second denominator is a trinomial. So this one is x squared plus 10x plus 24. So remember, when you're finding your least common denominator, you don't want to decide what the LCD is until after you factor both of these expressions. So on this one, I can hockey stick out an 8. And then on this one, I'm going to t-chart it. And so the two numbers that times to give me 24 that add to give me 6, or that add to give me 10 are 6 and 4. And so when I go through and when I find the LCD for this one, I want to look at what they have and what they need. So this one has an x plus, or let me rewrite this one for you first. Here you go. So that's what this denominator turns into, and that's what this denominator turns into. They both have an x plus 4. This one has an 8, so if you were going to make them match, this one would need the 8. And then this one has an x plus 6, so if you were going to make them match, and again, you don't actually have to go through the adding part, but that one would need an x plus 6. So for this problem, if you were going to add or subtract them together, your LCD would be 8, x plus 4, and x plus 6. And it's worth me mentioning, too, that these can be written in any order, so they don't necessarily have to be written in this particular order. Let me just focus this. So when you're writing them down, multiplication's commutative, so you can write these down in any order, and you're fine. 15 says, my denominators for 15 are x squared minus 7x plus 6. And then my second denominator is x squared minus 2x plus 3 minus 3 plus 2x minus 3. There we go. So when I do the work for this one, I'm going to t-chart both of the bottoms, and you do want to be careful when you're t-charting. Remember to double check that the product for the inside-outside part of FOIL does add up to give you that number. And so when both of my denominators are t-charted, if I was going to go through the work of either adding or subtracting these expressions together, they both have an x minus 1. This one has an x plus 3, so this one would need the x plus 3. And then this one doesn't have the x minus 6, so this one would need the x minus 6. And so if you were going to add or subtract them together for this one, your least common denominator would be those three numbers written out as a product. And again, it doesn't matter what order you write them in, but you would have to have a minus 6, a minus 1, and a plus 3 in your product. And again, they can be written in any order. So up till this point on the review, we haven't actually done anything with the two fractions in terms of combining them. On question number 16, we start a section of 3 where the directions say to find the product and then to simplify completely. So x over 7x minus 14, and then I'm timesing it. So make sure you notice it's two fractions, but notice that the dot in the middle says multiply. and then this one's x minus 2 and x plus 5. So when I do the work for this question, I want to make sure I can't just randomly start crossing things out. I need to make sure that all 4, so top, bottom, are factored completely before I start. So on this one, I can hockey stick out or GCF out a 7. And so before I find my final answer to this question, I want to rewrite this in factored form. There will be some things that can cross out, but you just want to be careful about collecting everything that you have left over before you find the answer to the question. So for this one, I have an x in the top and a 7 and an x minus 2 in the bottom, and then an x minus 2 in the top and an x plus 5 in the bottom. And so now it is the case that this one can cross out with this one, and then you just collect back everything that you have left over. So in the top, all I have left over is an x, and then in the bottom, I have a 7 and an x plus 5. You could do the distributive property, but it is more common to leave the answer written in factored form. So this is what you get when you multiply these two together. 17 is also a multiplication question. X minus 9 over 12x, and I'm multiplying that by this expression, or this rational expression. And again, you don't want to start trying to cross things out until after everything is written in factored form. So for 17, I can GCF out a 5 and an x from this one. And so my first expression stays the same. And then my second expression becomes this product. And so now I can go through the work of actually crossing things off. So factoring first is really important when you're doing multiplication. This one crosses out with this one. And then there's also a little bit more simplification that can happen on this question as well. Notice that the 3 and the 12 can simplify. So 3 goes into 3 once, and 3 goes into 12 4 times. And so that'll help you finish simplifying the question. When you're finished on this one, you have nothing left on the top, so there's just a 1 left in the top. Don't forget that 1. 4 times 5 is 20, and x times x is x squared. So this one gives me 1 over 20x squared. If the 1 that you have left over is in the bottom of your fraction, you can choose to omit writing the 1. But if the one that you have is in the top of your fraction, if everything crosses out in the top, you do want to make sure that you put a 1 up there. 18 is the last multiplication question. And so again, when the directions say multiply, when you see this dot that's in the middle, it means that you're going to factor everything that you can factor, and then you'll simplify by crossing out any of the products that can cross out diagonally or also up and down. So this is a hockey stick. So I'll take out a 2x and then I'll have x plus 3 left over. This one's a t-chart and this one's a t-chart. This is a difference of 2 squares. And then on this one, numbers that times to give me 30 that add to give me 7 are 10 and 3. And I want the 10 to be positive and I want the 3 to be negative because the 7 was positive right here in the middle. I do go through the step of writing it all out because I want to make sure when I cross things off, I don't miss anything. And so on this one, there's a couple things that can cross off. X minus 3 can cross out with x minus 3. X plus 3 can cross off with x plus 3. This 2 down here is stuck, so you're still going to have the 2 on your answer. But this x that's out front right here can cross out with one of the x's that's on the top. So when I'm finished on this one, I'm still going to have an x left over on the top. That's all that's going to be left over on the top. And then in the bottom, I have a 2, and I have an x plus 10. And so this would be the most common way of writing my answer to that question. Again, it's standard that you don't do the distributive property out on the bottom. It's more common that you just leave it how it is. So on 16, 17, and 18, we had 2 fractions. We weren't finding a least common denominator. On 16, 17, and 18, we were multiplying them together. And so on 19 and 20, the directions to these questions say to divide. So when you do the work for these ones, there's just that one additional step that you want to remember. So I'm dividing on this one. So when you're dividing, the rules kind of follow the same as multiplication. I know I'm going to need to factor this one, and so I can go ahead and I can do the work there. But when I rewrite this, the first one stays the same. The divide symbol changes to multiplication, and then this second fraction flips upside down. division of a fraction or division by a fraction is the same as multiplying by the reciprocal of that fraction. So before I start crossing things off, I want to make sure I flip it. I don't just flip it so that things cross off. I flip it because that's what the rule says. And so these two cross out here and here. And for this particular question, that's everything that crosses out. Be careful. This x is with the 8, so it can't cross out with this x. So I have a 7 and an x plus 8 in the top, and then I have an x left over in the bottom. And so that would be the best that I could do. So question number 20 is also a division question. And so question number 20 says x minus 2 over x squared plus 7x minus 18. So on this first fraction, this one's not going to need to get factored, but this one will get t-charted. And then I'm dividing it by this. This one's going to need to be hockey sticked or GCF'd and t-charted, and then this one's just a t-chart. So there's a considerable amount of factoring that happens on this problem. Make sure that you factor slowly enough that you're careful to find the correct products that multiply back to give you those numbers. This one will be x plus 9 and x minus 1. And then on this one, as I mentioned, you're going to need to hockey stick or GCF out an x. And so I'm going to GCF or take out that x right here, and then I'll t-chart what's left over, and I'm just writing that up above for sake of space. Now that everything is factored, I'm going to rewrite it all before I start crossing things off. And you're going to want to, decide if for you it needs to be written out or not. Remember, the first fraction stays the same. And then the second fraction, once it's factored or after it's factored, you can go ahead and you can write it down in factored form. But remember, you're flipping the top and the bottom. It changes to multiply, and then this fraction flips. And so my x minus 2's cross out, my x plus 9's cross out, and then I want to just look at the things that are left over to see if there's anything else in this problem that I can eliminate, but there's not. So out of all the things that are left over, in the top I have an x minus 1. I don't need to put parentheses around that because it's not being multiplied by anything else. And then in the bottom of this fraction, I have x minus 9, and I have x plus 3. This problem is actually a really good point for me to mention that it's not necessarily wrong if a bunch of stuff doesn't cross out, but if you notice that you have a ton of parentheses left over in your answer, you might want to go back and double check your factoring to make sure that you didn't miss anything along the way. 19 and 20 are the end of the division problems. So if it's division, it's just like multiplication, except the second one flips upside down. On question 21, we start a section of adding. It says perform and subtracting. It says perform the indicated operation. So there's still going to be factoring involved in this one. This first one's an addition question. Remember, you see two fractions, but you want to look in between them. On this one, in between the two fractions is a plus sign. A plus sign means that I'm going to need to make the denominators match. But before I make them match, I want to make sure they're both written in factored form. So if I factor my second denominator, the denominator that was there turns into this. And so for this problem, the two denominators are not as different as they may have originally appeared because this second denominator over here already has the x plus 2. So to make them match, to do the part that you're doing the matching, it's just this one that's going to need something added in. I'm going to work vertically on these problems instead of horizontally. So I haven't made them match yet. All I did was I changed this one and I wrote it in factored form. And now to make them have an LCD, this one needs the x minus 1. And so here I'll distribute. So this is going to turn into x over x plus 2 times x minus 1. And then this one's going to turn into x minus 1 over x plus 2 times x minus 1. And now that I've made the bottoms match, I'm ready to add them together with one another. So I'll do top plus top. X plus x gives me 2x. The 1 doesn't have anything to add with, so it just stays minus 1. And so this one's going to be a 2x minus 1 in the top. And then the x plus 2 and the x minus 1 can get written in either order in the bottom. So it doesn't matter which one you write first and which one you write second. If you're adding and subtracting, you don't necessarily have to work vertically. I was just making the change to do the work this way for this problem. But make sure the bottoms have to match. But when the bottoms match, you don't go through and cross them off. So you're just doing the work to have the bottoms match to get the answer to that question. For question number 22, here I'll go ahead and do that on another page. Question 22 says 3 minus x over x plus 11 over 3 plus x. And so if you don't like the way the denominators are written, you could always switch them, but there's really no harm in having them written the way that they're written. You're going to make them match. You can't make them match by just adding 3 to this one because you have to use multiplication to make them match. So when I do my workout for this question for 22, I'm going to want to make sure that I show all the steps that I need to get the answer to that question. So let's see. This one's going to need the x, and this one's going to need the 3 plus x. And I'm going to have to be careful when I multiply out the top on that one. So FOIL, so that top is going to give me 9 plus 3x minus x squared. And then my bottom is x. And when the bottom gets written, you're not going to multiply or distribute out the bottom. You're usually just going to leave it the way it's set up. Plus 11x over x times 3 plus x. So the bottoms match, which is good. And when the bottoms match, it means you can add everything together. So when I combine these together in the top, I'm going to have negative x to the second. These 3 x's are opposites, so they cancel. Plus 11x plus 9. It would be worth trying to t-chart the top on that to see if this could t-chart to simplify, but it can't. And so it's fine to leave your answer written in this format. You may also see your answer written with a negative 1 factored out to the front, but this is fine to leave your answer just like that. 23 is a subtraction question, and so because of the fact that it's subtraction, we're just going to want to make sure we're careful with that minus sign that's in the middle, because depending on the problem, it might mean that something has to get, subtracted, or there's going to be a minus, and you just want to be careful with that. Remember that you're not going to subtract them until you check that both of the bottoms are in factored form, and this one can t-chart. So before I even go through the work of making them match each other, I want to make sure that both of my denominators are written in factored form. And so now they're both written in factored form, so now I'm ready to make them match. But to make these ones match, they both have an x plus 5, and so this one needs an x minus 5. And that'll make the bottoms match. This will require foiling here, and so I'm going to fix that fraction before I do the work and add them together. So x squared minus 5x plus 4x minus 20. And then I might even do the one more step and simplify these together before I do the subtraction, just because you want to be careful with the signs when you do your subtraction. So x squared minus 1x minus 20. So before I write my final answer to the question, I'm going to make sure I recognize that this is a subtraction problem. The bottoms match. Even if these two in the bottom were backwards, it would be fine. They would still match each other. Remember, when it's subtraction, it's going to change the sign on this one, it's going to change the sign on this one, and it's going to change the sign on this one. So when I add these all together, I'm going to get negative x to the second. This x doesn't have anyone to combine with, so it's just going to be plus x. And then it's going to be 1 plus 20, not 1 minus 20, and so it's going to be 21. And then here's my denominator. It would be worth trying to t-chart the top, but on this problem, the top doesn't t-chart, and so this is your final answer. On 24, this is our final question where we're subtracting two expressions. Remember that on each of the problems, I feel like I've tried to emphasize this, but you have to look at the sign that's in between them to see what the question's asking you to do. So if this problem had a multiply sign right here, it would be very different than what we're going to do to subtract it. If this problem had, I don't know, an equal sign, we're about to do that in a second, but if it had an equal sign right here, then it would be very different. So this is two fractions with a minus sign. I know that to add or subtract fractions, I need the bottoms to match. This is what you get when you t-chart this one. So x over x minus 6 times x plus 5. And so then on this one, it's going to need the x minus 6 to make it match. So you're trying to do the math to make the bottoms match so that then you can add them together. So this one stays the same so far because I haven't added it up with the other one. And then on this one, I'll do my distributive property here. And then before I combine them together, I want to be careful because this negative is going to change the sign on the x, and it's going to change the sign on the 6. X take away x are going to go away, or sorry, x plus negative x will go away. And so for your final answer for this question, I'm going to have a 6 on the top, and then in the bottom, I'm going to have x minus 6 and x plus 5. And those numbers on the bottom can get written in either order. So it doesn't matter which term comes first and which term comes second, or which factor comes first and which factor comes second. They can get written in either order. So 24 wraps up the addition and subtraction questions. The last section on this part of the review, or the last section on this review, is solving rational equations. And so the work that your teacher has you do for this might look a little bit differently than the way that another teacher teaches it. So just, right along. The way that we do it here is fine. It just might look a little bit different in your notes. So anytime you have a rational equation, you know it's a rational equation because there's 3 parts. There's an equal sign. If they're not fractions, all 3 of them, like looking ahead, there might be one, like question 27, just has the number 7 here. It still has 3 parts. But you know that this is different than anything we've been doing so far because these ones have an equal sign. You're not multiplying, you're not dividing, you're not adding, you're not subtracting. Well, I mean, you are adding. But there's 3 parts and they have this equal sign. So as soon as you see this equal sign, that's how you know that this is going to be a question that's asking you to do something different. One strategy you can use to solving these problems is you can make all the denominators match. So this one has an x in the bottom, this one has an x on the bottom, so this one would need the x. This one has a 4 in the bottom, so this one would need the 4, and this one would need the 4. Once you go through and make all the bottoms match, you can use the property that says that in an equation, if you have 3 fractions that are a part of an equation and if the bottoms are equal, it follows that the tops have to be equal. So in our class, we crossed out the bottoms and we create an equation with just what's left over from the top. No more fractions. 20 plus 7x is equal to negative 36. So this is what I got from the top part after I made the bottoms be equal to each other. And now I'll just go through and I'll finish solving this. 7x is equal to negative 56. X is equal to negative 8. And then before I decide on this being my answer, remember that I have to look back at the question. X equals 0 would have been an excluded value for this problem, so I wouldn't have wanted x to equal 0, but since I got x equals negative 8, that's my answer to the question. And so that gives me the answer to the question that I need to get for this problem. If I got x equals 0 as an answer, I would throw it away, and if x equals 0 was the only answer, then I would say that the question had no solution. So 26 through 29, the process is the same. The only thing that's different is on some of them you might have to factor. Writing down the question to get started is a helpful first step. So on question 26, 3 over 2 plus 4 over x minus 1 is equal to x plus 1 over x minus 1. So again, I know that this is different than some of the other questions I've been doing so far because on this one, there's 3 parts, 1, 2, 3, and there's an equal sign in the problem. And so that's what tips you off that this is going to be a little bit different. So that equal sign tells you that you're going to be doing something that's slightly not the same. This one needs the 2. This one needs the 2, and this one needs the x minus 1. In this rational equation, once I've made the bottoms match, I can say that the bottoms are equal, and so I can create an equation based off just what's in the top. And then solving this equation, taking what was in the top and solving it, is just going through and finishing the algebra steps. Be careful with your distributive properties. Combine like terms. Make sure not to go, as I make a mistake, make sure not to go through too fast through the solving steps for these. And so when you arrive at an answer for this one, for question number 26, the answer is x equals negative 3. Come back up to the beginning. X equals positive 1 would have been my excluded value because that would have been the number that made the denominator initially equal to 0. And since I got x equals negative 3 as my answer, it means that that's fine, and that is the solution to the question. So x equals negative 3. On 27, one of my denominators is x minus 2. I have the regular number 7, which we'll deal with in a second. And then I have 10 over x minus 2. It could help you before you get started to recognize that this 7 does have a 1 that's in the bottom. In order to have this rational equation have the thing happen where the bottoms cross off, where you can use that property, you don't have to give these ones a 1, but you do have to recognize that this guy is going to need the x minus 2. So just because it didn't have a denominator typed on the paper originally when you did the question, you do have to make sure that you give it a denominator so that it matches. When the bottoms are equal, you can create an equation out of just the tops. And then I'm going to go through and I'll solve that equation, and this will yield my solutions, if any. Distributive property. And then I'll move the 7x over here, which is just one way of solving it. And divide both sides. So I do the work on this problem, I get x equals 2, but I want to be careful because this is a fake answer. This is an extraneous solution. If you look back up at the beginning, x isn't allowed to equal 2 because 2 would make a 0 in the bottom. So you cross this off and you say that this question has no solution. So if you got x equals 2 while you were working on the review, and if it said that on the back of the paper it says that it's no solution, that's why. Because this answer was the bad number that you weren't supposed to get, and so that's why that question has no solution. That won't happen a lot, but it could happen on problems, so you just want to be careful and keep your head up that it might occur. On question 28, 1 is equal to 2 over x squared minus 1 over x. So same thing, I know that this is a rational equation because it contains 3 components and it has an equal sign. This one has a 1 in the bottom, and so I'm trying to make the bottoms match. Remember that you want to do the least amount of work you need to make the bottoms match. So this one has 2 x's, so this one would need 1x to make it match, and then this one would need 2 x's to make it match. And so all you have to do is make the bottoms match. You don't have to make them all have 3 x's, although if you did, if they made them all have x to the third, you could still follow through with this process. When the bottoms match, I can create an equation just from the top, and then I can go through the process that I would need to solve this. Notice how this one has an x squared, and it has an x in it, and so that means that when I'm doing the work that's about to follow, I can't just put the x's on one side, the numbers on the other, and solve from there. I'm going to have to factor to solve this problem. So I'm going to move the x over to the left side of the equal sign, and I'm going to move the 2 over to the left side of the equal sign. So I need to set it equal to 0 before I can factor to solve. When I t-chart this, I'm going to get positive 2 and negative 1. So I get x plus 2 times x minus 1 is equal to 0. And I'm trying to solve to find the numbers that x can be. A lot of times students get stuck on knowing when you're supposed to factor. So kind of just keep the general rule in mind that if you see a squared, it means you might have to factor to get an answer to the question. Go back to the original. The only number that would have been bad is if you got x was 0 to start with, but you didn't get 0. You got negative 2 and positive 1, and so these are your 2 solutions for question 28. If one of these was this number, you would cross it out. If there were 2 excluded values, and if you got those same 2 numbers here, both solutions would be extraneous, and you would say that the problem had no solution. And last but not least, all right, so for this one, you don't want to try to start making the bottoms match. Notice that there's 3 parts. You will have to make the bottoms match, but this bottom over here, this denominator, isn't written in factored form yet. So you want to factor that denominator before you get started. So before I even start trying to make the bottoms match each other, I'm going to rewrite this denominator so that it's written in factored form. This one has an x plus 1 and an x minus 1. This one only has the x minus 1, so this one's going to need the x plus 1. And then this one only has the x plus 1, so this one's going to need the x minus 1. Notice that the numerator on this fraction didn't need to have anything multiplied to it because it already had both parts of the bottom. I'm going to cross out my denominators, and I'm going to write down the resulting equation that comes from the numerators. I'm usually pretty careful when I write this down, and I don't do the distributive property until the next step. So 7x minus 7 minus 3x minus 1, that's not 1. That's the whole point. Minus 3x minus 3, not plus 3, because you're multiplying a negative 3 here. And then I'll combine my like terms here and here. So that's going to give me 4x minus 10 equals 6. I'll get 4x equals 16. And so when I finish this question, I'm going to have x equals 4 as my answer. I go back up to the original question. The two numbers that would have been bad for this one would have been positive 1 and negative 1, but I got 4 as my answer, so I don't have to worry about 4 being an extraneous solution. That's my answer to the question.